I just made an 11-minute video for 1 through 8, and I didn't hit record. So I'm going to take a deep breath, and I will open the floor to questions that you have 1 through 8. We can go over it, but I don't think I could possibly re-explain 1 through 8 again at this time of night. So I apologize. I'm recording. I see that recording. I see that recording. We're good. But I'm going to start with 9 because I didn't throw anything. That's good. Yeah, let's go ahead and start at 9. And so we got a binomial here that are radicals, and can't combine those two because they have different radicands. But I can multiply the 15 and distribute them, and who knows what might be able to happen. I might be able to simplify these guys so they can combine, which is pretty cool. 15 times 5, that would be 75. Okay, so now let's see what's inside these guys. I'm going to have to look at their DNA. So we got 9 and 5, and then this would be 25 and 5, right? Yeah, no, 25 and 3. Okay, so a 3 is coming out. Okay, and then this guy would be minus, a 5 is coming out, and then we'd be left with a 3. And I know it feels like we should be able to combine those, but you can't. They're actually stuck because the radical 5 and radical 3 are unlike terms. All right, so that's that. And then we've got this guy. So this is foiling. You know, I don't even like the word foil, but I can't help it. I've been trained to say foil so many times. It's really just binomial distribution, you know. But that's no, can't say that. Because binomial distribution is something else in statistics. But anyways, we're going to do 7 times 1, and then 7 times 4 with the radical 2 attached. And then we're going to go ahead and he's done. So now we go here for we got the F and the O part. So now we're going to do the inner for the I in foil. And so now we just got radical 2 times 1 is just radical 2. And then we got a negative radical 2 times a negative 4 radical 2, that's going to be positive 4 square root of 4, okay? All right, now this guy's going to be 8, because radical 4 is 2, 4 times 2 is 8. 7 and 8 actually will combine, so those guys will combine together. These are both radical 2's, and so this guy will bump up to negative 29 radical 2. And again, notice that this coefficient here is a negative 1, so those will just combine with the 28, and there's our guy. Okay, I won't even bother writing the answers. I did post the answer key. You probably already saw that. Okay, now, what I want to do is I want to clean this up before I multiply. Like, I can't have a radical in the denominator. And so I'm going to leave that there. But I'm going to clean this up a little bit. I do see that inside there is a pair of 3's and then a 2. And you'll see why in a second, why I'm going to want to clean this up. It should be 2 radical 5. All right. The 8 is there, so if I took out a pair of 3's, the 8 gets bumped up to 24, and the 2 is left over. So this means that I don't have to multiply by a radical 18. I can actually just multiply by a radical 2, okay? Which is a significantly smaller number, and I actually don't have to use my calculator here, because now on the top I've got 2 radical 10, and then on the bottom is a 24 radical 4. Now, if you did multiply 18 times 18, yeah, it'll still work out, but you're also going to have 5 times 18, just a larger number, more to break down. Break it down as small as possible and then multiply by the radical, okay? So 2 over radical 10, okay? Now that radical 10 is going to stay radical 10. That's going to be 48, and then it looks like 2 will go into both of those, so I will have a 24 and 124, so radical 10. Radical 10 over 24. It looks like it should be able to reduce, but it cannot. All right, this guy is, we're going to break that radical here. Okay, split it up so that we can possibly free anything that can. Now this radical 3x, there's actually nothing I can do to break that guy down, so I actually will multiply by radical 3x like that onto the top and the bottom. Remember, this is 1, okay? And all we're doing is we're not changing the number, we're changing its form so that we can simplify it and use it in easier things down the road. Which, you know, in this class, kind of tough to see, like what do we use all this stuff down the road for? And you know, you really don't get to see, I think I say this too much, you really don't get to see the punchline until like in calculus, like why we do it. It's like all this stuff is assumed that you are just, it's instinctual. Okay, so let's see, what is the highest? 5? Nope, that's 80. So what is the highest? 12 times 5. So that would be 4 times 15 and 15. So 2 radical 15x and 3x. And that's it. You can't go any further. We took out a pair of 2's in there. There's 4 times 15. The x does not have a pair. You think these might cancel, but they do not. There's just nowhere to go. Okay. So this guy and this guy are equivalent. They are the same. All right, so now we've got a radical 12. So let's go ahead and shrink that guy down just a little bit. Okay, I know that there's a pair of 4's in there. I'm sorry, a pair of 2's in the 4. And so 2 radical 3. Okay, so now I've got to multiply, not by 2 radical 3. I don't have to. I can just do radical 3. Okay, just focus on the radical when they're monomials. Okay. All right, so now 3, we're going to distribute. Now this times this will actually end up being 6. Okay, so radical 3 times radical 3 is just 3. 3 times 2 is 6. Let's see, so 3 radical 15. And then we're going to distribute it to this guy, which would be minus 2 radical 9, which is 3. So that would be minus 6. Okay, now here's something interesting. You'll notice that the 3, the 6, and the 6 all have a 3 in common. Oh, you can't see. They all have a 3 in common. So let's divide everything by 3. Okay, and that's it. I can't go any further. All right, what time are we at? We're at 7. Okay, 7 and almost 8 minutes. All right, so we'll do this one, and then we'll stop there, and then we'll go ahead and do those guys. Okay. All right, now this one is a little bit more complicated because it's not a monomial, it's a binomial. All right, and so we've got to multiply by the conjugate. All right, so conjugates are for binomials, and so we'll just go ahead and put parentheses around these guys so that it looks familiar to us. We know that we can always FOIL whenever we see 2 sets of parentheses next to each other over addition or subtraction. And so we will go ahead and get ready for the long multiplication here. 5 radical 3 times 2 is 10 radical 3 plus 5 radical 3 times radical 3 would be 15. All right, because radical 3 times radical 3 is 3. 3 times 5 is 15. All right, I do see a common factor here, so I'm going to keep my eyes open. My head open. My eyes open. All right, now let's FOIL this guy out. So we get 4, and then we get a positive 2 radical 3, and then we get a negative 2 radical 3. That should happen every time. And then we get a minus 3. Okay, so minus 3. So that actually is 4 minus 3. These guys canceled out, so that's 1. So it looks, oh, that is our final answer. And we can't do anything to those 2, even though it looks like it, because this guy is a radical 3. He does not, so we are done. Okay. All right, that's the first batch